So we started looking at probability in a previous video as we discussed the fundamental counting principle. In this video, we're going to talk about the basic fundamentals of probability itself, our objective, compute the probability of an event happening. Well, let's first define probability. Probability is simply the chance that something will happen. Okay, two ways we'll see it. I found this online, a nice little line that gives you a sense of it. So probability can be shown on a line, and basically probability goes from impossible to certain. Okay, so probability being the chance that something will happen, that something is happening is either impossible, no way it's going to happen, or it's absolutely going to happen. These are your two extremes. Now, in numbers or fractions, that goes from 0 to 1. So probability is never less than 0. There's no such thing as negative probability. And if something is certain to happen, and the probability of certainty is a 1, which stands for 100%, there's no chance that the chance of it happening is greater than 100%, because in this situation, there's no such thing. There's no such thing as something having a greater than 100% chance happening. So between these two, we have things that are unlikely if they're less than 50-50. And we have things that are likely if they're more than 50-50. And of course, 50-50 is an even chance. So we have here rolling a die. A die has 6 sides. So there's a 1 in 6 chance of a particular number coming up. It's less likely that you'll roll a die and get your number to come up. Okay, because you're only looking for the one number and there are 5 other numbers. Okay, over here in the likely column, if you have 5 balls and 4 of them are, let's say, red and 1 of them is blue, and the chances of picking a red one, well, there are 4 red ones. So your chances are pretty good for picking a red one because there are more red ones than blue ones. Out of the 5 balls, 4 are red, so you have a 4 in 5 chance of picking a red. So the important thing here is probability goes from 0 to 1. If you're exactly 1/2, even chance is the proper fraction 1/2. That's an even chance, a coin flip as an example. But 0 means it's not going to happen. It is impossible. The probability that I jump over a 10-story building, not going to happen, impossible. A 1 meaning that it is certain. Okay, it absolutely is the case. Okay, normally, so that's a nice little picture. Normally when we work with probability, though, we tend to see it in numbers, and usually we see it in fractions and percents. Oftentimes it's percents. Probability is probably the most popular probability has to do with weather, and the chance of rain or the chance of snow is always probability. So you always see that as a percent. As we mentioned up here, the probability of an event happening is always between 0 and 1 in fractional terms, 0 over 1 and 1 over 1. So you have proper fractions between 0 and 1, or it's between 0% and 100%, 20%, 30%, 75%, etc. Okay, so those are your extremes, 0 to 1, or in percentage terms, 0 to 100. And as I mentioned above, a probability of 0 or 0% means it's impossible. A probability of 1 or 100% means the event is certain. Okay, so here is the base calculation or base fraction for probability. The probability of an event happening. Okay, the denominator we talked about in the previous video with the fundamental counting principle. If you don't know or you have to calculate the total number of outcomes, you use the fundamental counting principle. However, you often know this. So your denominator is always the total number of outcomes. Your numerator is the number of ways what you're looking for, the event, can happen. Okay? So probability is a fraction, which can be changed to a percent, of course. The number of ways the event can happen over the total number of possibilities, the total number of outcomes. Notation. In mathematics, the letter P is used to mean probability of. So if you write P with parentheses, P of P event, probability event, this stands the probability of this event. Okay, so this P, probability of this event. Let's take a look at two examples to help us get squared away a little bit on this. I'm going to get my paper situated. Okay, so a die has 6 sides. We saw that above. A, what is the probability of rolling a 5? Okay, so letter A. Probability of a 5 will look like that in mathematics. Probability is a fraction. The denominator is total number of outcomes. Well, a die has 6 sides, so there are 6 outcomes. Okay, if you can roll it, you get 6 possibilities, 6 different possibilities, 6 different outcomes can land up face up. Okay, number of ways a 5 can happen out of these 6, well, one of those sides is a 5. So the number of ways that a 5 can happen is 1. 1 out of those 6 is a 5. There's 1 5. As a percent, do this, we can change our fraction to a percent. This is approximately 16.7% rounded to the nearest tenth. Letter B. What is the probability of getting an even number? Okay, so the probability of an even. Okay, first off, the denominator. How many outcomes are we talking about? Well, it has 6 sides. The denominator is a 6. Okay, how many of these outcomes are evens? Okay, how many ways can we get an even to happen? Well, the even numbers are 2, 4, and 6. So there are 3 ways to get an even number. Of course, this fraction can be simplified. So there's how you would write it as a simplified fraction. And you all know that 1/2 as a percent is precisely equal to 50%. Last example, last piece of example 1. What is the probability of rolling a 7? Okay, so probability of rolling a 7. Okay, well again, total number of outcomes, we got 6 outcomes. That die has 6 sides. How many of those outcomes are a 7? How many ways can a 7 come up? Well, there is no 7. 0. There's no way you're going to roll a 7. The 7 is not on the die. It only goes from 1 to 6. So here's an example of a probability of 0, or 0% means the event is impossible. Here's an example of impossible. Take 1 die, roll me a 7, please. Not going to happen. There is no 7. That's impossible. Okay, that's impossible. So there's some examples there of some basic probability. Let's take a look at another example using some data that's provided that we know about. Okay. All right, so example 2. Let me get my notes turned over. The table below shows the number of people, let me get myself straight, in the U.S. living alone in millions. So 0.7 is 0.7 million, or 1.4 million, or 3.8 million. So it's in millions. Okay, and you notice we have a total here. Okay, so we have, according to this table, there are 29.3 million people who are living alone in the U.S. I don't know when they came up with these numbers, and it's broken down as follows. Males that are between these ages, we have 0.7 million. Females between 35 and 44, we have 1.6 million. All females, there are 16.8 million. All ages 35 to 44, 4.2 million, etc. So we're going to use our table here, our chart, to answer these probability questions. Letter A, probability the person is male. Okay, probability of being male. P with an M in parentheses. Okay, total number of, in this case, people, 29.3 million. Okay, and we're looking for how many of those are males. This is our event. We want males. Well, I'll look at the total number of males, and I have 12.5. So that's our fraction. Now, of course, in this case, leaving it as a fraction like that, nobody's really going to do, because that's just kind of confusing. The vast majority of times you'll see this just represented as a percent, because it makes a whole lot more sense to most people. And this is approximately 42.7%. So a little less than half of the folks living alone in the U.S. are male. Letter B, the probability the person is in the 25 to 34 age range. Okay, probability that the person is in the 25 to 34 age range. Okay, again, denominator. What's the total number of people we're talking about? 29.3 million. Okay, how many of these people are in this age range? How many of these people are in this age range? Okay, well, here's 25 to 34. We have men and women. The total number of folks in this age range is 3.8 million. And again, you'll more than likely see this expressed as a percent, because this fraction really doesn't, it's a little more confusing to work with. I rounded it to the nearest tenth, and I got approximately 13%. 13% of this number of people living alone are in the age range from 25 to 34. Okay? And letter C, the probability the person is a female in the 15 to 24 age range. So I'm looking for a 15 to 24-year-old female. Okay? All right. Again, total number of people we're talking about, 29.3 million. I'm looking for these people, the 15 to 24-year-olds that are female. Well, here's the 15 to 24-year-old column. Here's the female row. It looks like I have 0.8 of a million, or 0.8 million, that fit this criteria. So I have that number of 15 to 24-year-old females who live alone out of a total who live alone of 29.3 million. And again, as a percent, this is approximately 2.7%. 2.7% of these 29.3 million are females between the ages of 15 and 24. So there you go, probability. Again, primary focus on the fact that probability is always going to be between 0 and 1, or between 0% and 100%. As a fraction, it will always be a proper fraction. Okay? And then here's what we're looking to do. The denominator is the total number of outcomes. The numerator is the number of ways what you're looking for can happen.